All right, so next we're going to talk about is solutions of quadratic systems. Now, the quadratic systems could be a linear quadratic system, which means that we have a linear equation with a quadratic equation, or it could be just a quadratic system where both equations are quadratic. But now, first one that we're going to do is just through graphing. Now, we're not going to actually graph it. I'm just going to go to a website and we'll graph it on there. But when we're looking for the solutions through graphing, we will graph both of our equations, whether if they're both quadratic or one's quadratic and one's linear. And if our line intersects, or if our two graphs intersect at 2 points, then that means there are two solutions, because these 2 points will satisfy both the linear equation and the quadratic equation. So we have two solutions. If we only have one intersection here, where our line intersects at the top of our vertex, then that means that we only have one solution, because our graphs will only intersect or touch at 1 point. And that 1 point is the only point that will satisfy both the line and the quadratic. And then if we have a case where they don't touch at all, so here's our linear equation, here's our quadratic equation, they don't touch, they'll never touch, that means that there is no solution. There's no point that will satisfy both the quadratic equation and the linear equation at the same time. All right, so now we're just going to do one real quick through graphing, and like I said, we're not going to actually graph it. We're just going to go to a website and talk about the answers, and then after that we'll go through solving them algebraically, and then we'll do systems of quadratic inequalities. All right, so let's go on to the next example. All right, so if you're given the system of equations that we have here, that y is equal to negative x squared plus 5x plus 6, and y is equal to x plus 6, and we're asked to solve for this system of equations. Well, one method that we can do is graphing. So if we were to graph y is equal to negative x squared plus 5x plus 6, is we would get this graph here. All right, so that means any point that falls on this graph where our x and our y will satisfy this equation. So if we pick this point here where x is equal to 6 and y is equal to 0, when we plug it in, negative 6 squared will give me negative 36, and then 5 times 6 gives me 30, so negative 36 plus 30 is negative 6, plus 6 gives me 0. So any point we pick on this graph will satisfy our equation of y is equal to negative x squared plus 5x plus 6. So when we go to solve for this system, we need to graph both. And when we graph both, where they intersect is our solutions. So here we have the intersection here, and we have the intersection here. This intersection is at the point 4, 10. So that means when x is 4 and y is 10, that satisfies both of our equations at the same time. And then the other answer is when x is 0 and y is 6. That means that satisfies both equations at the same time. Graphing can be useful if both of your answers are going to be a whole number, but graphing at times can be very tedious or hard to get your actual answer, because if it does not intersect at a whole number and it intersects at maybe where it was 1/2, it might be hard for you to determine that exact value. So when you're solving through graphing, you just need to graph both and you look to see where they intersect. If they intersect at 2 points, then we have two solutions. If they intersect at 1, then we have one solution. If they don't intersect, then we have 0 solutions. All right, and it could be, in this case where we have a quadratic equation with a linear equation, it could be two quadratics, but we solve them through graphing and looking for their intersections. All right, and then that's it for this video for solving quadratic systems through graphing. Next, we're going to get into doing it algebraically.